Hello, this is Joseph Alds for Project 3, IR RPM Measure and Transmission for Software Development for Real-Time Operating Systems at Johns Hopkins University. The project requirements are to write a C program for an Arduino that uses Red Robin with interrupts or function queue scheduling. I chose to use Red Robin with interrupts. Follow the instructions in Arduino-based optical tachometer by C. Palmer to calculate RPM, which is measured using an IR emitter and detector pair. Capture the RPMs over time, download them to a host, and create a graph of the RPM. Transmit the time in RPM via serial connection to the host. I will use interrupt that will be triggered on the following edge of a changed digital pin 2, and I'll delay every second to calculate the RPM over the previous second. And when calculating RPM, disable interrupts to ensure that the calculation can complete without being interrupted. Here's the project design. So it will power on. I will set up serial and the interrupts once. I will loop, calculate RPM, print in time and RPM to screen, and then loop. And then over here I have my interrupt. So the interrupt triggers on the falling edge of digital pin 2, and then I will increment RPM count. For the setup, like I mentioned, set up digital pin 2 falling edge interrupt, set up the serial connection, set digital pin 13 output and high to power on the photodiode and the IR LED. Initialize global variables to 0, and then print a welcome message and a header for the CSV file. Then for the loop, I'll delay 1 second, detach the interrupt, probably isn't necessary, but I just want to ensure that the calculation isn't interrupted. I'll calculate RPM for a 4-blade propeller. In my case, I'm using a fan. It calculates the current time the program has been running and outputs the time in RPM over serial to the host, and then re-enables the interrupt for the next cycle. This is a falling edge interrupt, so every time the voltage dips, it is triggered, and I will increment the RPM count in the interrupt. So here is a schematic of my hardware. So I have ground, and then I have power coming from digital pin 13. And then I have the interrupt on pin 2, which goes here. So this is my IR detector. This is my IR emitter. I'm using a 10K resistor here and a 333 ohm resistor here. I have the IR detector in reverse bias. So ground is actually going to power and power is going to ground. That's the typical way that these are used, so that when the voltage dips, it will detect a change on the interrupt instead of vice versa, where the voltage increases when it detects a change. I already talked about this. It's in reverse bias, and I have them powered digital pin 13 output to high. The software is written in C, and the software is compiled and uploaded via Arduino IDE. So here is a graph of me testing the fan. So like I mentioned, the fan is 4-bladed. So you can see it is turned on at about the 9-second mark. It goes up to around 2,500 RPM until I turn it off at around the 65-second mark, and it dips back down. Now I will talk about the code. So I have a global variable, the LED pin 13, some more global variables that I use to calculate how many times the interrupt was called between second delays. Here's the actual function that's called when an interrupt is detected. It just increments the RPM counter. Here's the setup, like I talked about. I initialized serial, attach an interrupt on the falling edge, output and high to power both the IR detector and emitter. Initialize all the global variables to 0, and then here's my header message. And here's the loop that runs continuously. Immediately delay for a second, so it's not printing out input all the time. I detach the interrupt. Here's where I actually calculate the RPM. So in my case, I have it set to 15 because it's a 4-bladed fan. If there was only 1 blade, it would be 60. 2 blades would be 30. 3 blades would be 20, etc. And then once I calculate it, I set RPM count back to 0 for the next iteration. Here's where I get the current time in seconds, and here's where I print the time and the RPM. And here's where I reattach the interrupt at the end. So now I'll show the code actually working. So I've had it running in the background. Right now nothing's happening. It's just sitting here. But if I do my finger, you can see that it is now detecting RPM. And it is not accurate for my finger. As it showed you in the code, it is for a 4-blade fan. So the calculation is not correct for the finger. But I can't actually turn on the fan while I hold the camera, but basically I just set it in there. I had to take the cover off to get it to fit. Set it in there and left it on for about 30 seconds. And here's the setup like I showed you on the schematic. And that concludes Project 3 demonstration. Thank you for watching.